So today we'll start with some basic questions and then gradually increase the difficulty level and move towards past paper questions as well. Okay, so let's take the questions that I gave you guys earlier to solve as homework. Now, and please make sure that you guys have the z table with you. Okay, I'm not going to be referring to the z table over and over again, although I will have to when I'm reading the value myself, but make sure that you have the z table with you. Okay, so the distribution of the masses of some baby parrots is normal, okay, and has a mean of 60 grams and a standard deviation of 5 grams. Okay, so that means x, which represents the masses of some baby parrots, is normally distributed with mean 60 grams and variance 0.5 square. Okay, we always, when we're writing down the parameters, we always write the variance, but in the formula we use standard deviation. Okay, find the probability that a randomly selected bird is under 63 grams. That means what do we have to do? We have to find out the probability that x is less than 63 grams. Okay, but before I go ahead and find out the probability, I need to first find out the z value of this value of x. Okay, now how do I find out the z value of this value of x? For that, I need to convert it into, I need to find out, I need to use the formula, which is z is equals to x minus mu upon the standard deviation. So let's find out the z value. So why did we take 0.5? Okay, why did I take 0.5? That's a good question. It should have been 5. Thank you for pointing that out, Laiba. It should have been 5. That was an error. Okay, so let's find out the z value. The z value is going to be 63 minus 60, which is the mean, divided by the standard deviation, which is 5. So let's work this out. 63 minus 60 divided by 5. So we're looking at 0.6. Okay, that means we technically have to find out the probability that z is less than 0.6. So can you guys quickly read the table and tell me what is the corresponding value of 0.6? You don't have to do a lot of hard work here.
Sir, 0.7257.
0.7257. Hang on, let me just open up the answers in front of me. This is normal distribution. Just a minute. 0.757, which, okay, I don't know why they've rounded off to 0.726, but anyway, so the probability of z is less than 0.6 is going to be 0.7257. Okay, that's it. This will hardly be a 2-mark question, or not more than that. Okay, so over 63. Sorry, someone saying something?
So like we have to write all of this that you have written on the left side, or just we can use a formula and just give the value.
No, you have to write everything that I've written. Okay, this is all the necessary work. Now for part 2, we have to find out the probability that it's over 63. That means you have to find out the probability of x being greater than 63, which means we now have to find out the probability that z is more than 0.6. Okay, we don't have to work hard for this one. All we have to do is 1 minus the p-value of 0.6. Okay, which is 1 minus 0.7257, that's equal to 0.2743. Okay, good job. Then let's look at part 3. Part 3 says over 68. Okay, so I'd like you guys to do this. I'd like you guys to do part 3 and part 4, and then we'll move on and do some past paper questions, okay, because these questions are fairly easy. Sir, you asked. Okay, yeah, I will. Not just yet. Okay, first I want you guys to have a good grip on solving this without a calculator. Then I'll tell you how you can use a calculator. I will tell you. Don't worry about that. Okay. So fairly easy questions. All right. Which is why we are now going to amp up the difficulty level and move on to some past paper questions. Okay. In past paper questions, you will come across questions where you have to maybe convert binomial into normal distribution as well. That's not what we're going to do today. Today we're going to practice this only. Okay, so here's a question which we are going to solve. Let's see what it says. So it's a fairly recent question. Okay, May June 2022, paper 5, question number paper 52, question number 4. Okay, so let's read what the question says. It says the weights in kg of bags of rice produced by Anders have the distribution so and so. Okay, so remember the way that you write normal distribution is that you write down the mean. So this is the mean, and then you write down the variance. Okay, now because variance is written as standard deviation squared, that means you can pick what the standard deviation is. Okay, without the square, it's the standard deviation. Find out the probability that a randomly chosen bag of rice produced by Anders weighs between 1.98 and 2.03 kg. Okay, so now in the first part, here's what we have to do. X is normally distributed or follows a normal distribution with 2.02 and 0.03 squared written in the question. We have to find out that the probability of X, or a randomly chosen bag of rice, is in between 1.98 and 2.03. Okay, so what do we have to do with these two values, 1.98 and 2.03? We have to first find their z-scores, or we have to first convert them into z values. The way to do that is we do x minus mu upon sigma, upon the standard deviation. So let's start with 1.98. 1.98 minus 2.02 over 0.03. Okay, and then for the other value, it's going to be 2.03 minus 2.02 over sigma, which is 0.03. Okay, so let's see what we get. Let's call this z1 and let's call the other z2. Okay, so z1 is 1.98 minus 2.02 divided by 0.03. So we have minus 4 upon 3. Okay, now minus 4 upon 3 means minus 1.333. Now up until how many decimal places can the table be read? What is the maximum number of decimal places that a z value can have? 3. Okay, so what does that mean? No, 3 decimal places. Okay, why 3, not 4? That's because you have 0 points. So here's the first decimal, here's the second decimal, here's the third decimal. Okay, so remember this is your second decimal place, and from here we pick the third decimal place. Okay, so the correct answer is 3 decimal places. So now if it's minus 4 upon 3, what we're going to take it as will be minus 1.333. Okay, we'll take it as minus 1.333. Then let's talk about z2. So for z2, here's what we're going to do. We're just going to change 1.98 in our calculator to 2.03. So now we're looking at 1 upon 3, and 1 upon 3 means 0.333. Once again, 3 decimal places. Okay, so here is what we now have to do. We have to find out the probability that z is less than 0.333 and greater than minus 1.333. Okay, which means, now going back to the rules, which means that we will have to do phi of 0.333 minus phi of minus 1.333. Okay, so before you start reading the table, make sure that you do this part of the working. So phi of 0.333, as far as that is concerned, that's pretty straightforward. We don't have to change this to anything. Okay, but as far as minus phi of minus 1.333 is concerned, what do we have to do for this? We know that there are no negative values on the table. So what do we do for this?
So we calculate for the positive one.
Yes, and we do.
So then we subtract it.
Yeah, so we do 1 minus phi of 1.333. Okay, so why are we doing this? Let's have a look. Like I said earlier, that I'll explain the rules as we go along. So basically, here's what we have to find out. What we have to find out is the probability that phi is in between 0.333 and greater than minus 1.333. So here is minus 1.333 and here is 0.333. So technically we have to find out this area. Now because it's symmetrical, what we can do is, instead of calculating this area, what we can do is we can, and this area will be calculated by basically doing 0.333, phi of 0.333 minus phi of minus 1.333. Okay, so instead what we're doing is, and this area I will highlight in red. Okay, So if I do 1 minus phi of 1.333, I end up calculating this area, which is the same as this one. Okay, so now what I'm doing is I'm simply doing the following. Phi of 0.333 will give me all this area, and then from that, when I do 1 minus phi of 0.333 and I subtract that, I end up subtracting all the other area, and what I'm left with is the green area. Okay, so this is the logic behind it. So let's write this down. 0.phi of 0.333 minus, in fact, plus phi of 1.333 minus 1. Okay, so once again, here's what we're doing. When we take phi of 0.333, we end up calculating all this area, the green one and the red one. Okay, in fact, let me highlight it with different colors. Let me highlight this with blue. Okay. Then when we take phi of 1.333, we end up adding the red, the blue, the green area. Okay, when we take phi of 1.333, we end up adding the red, the blue, the green area. Okay, and then when we subtract 1, now notice what's the one area that we have added twice. The one area that we have added twice is basically, so all the areas we've added twice. When we end up subtracting 1, what we do is we end up subtracting the red, the green, the blue, and the red area. So think of it this way. Let's call this P, let's call this Q, let's call this R, let's call this S. Okay, and notice that what we want is Q, and also keep in mind that area P is equal to area S. Okay, keep in mind that area P is equal to area S, so I'll just call this P. Okay, now when I take phi of 0.333, see if you guys can answer this question. When I take phi of 0.333, what is the area that I end up calculating? What are the areas that I end up adding when I take phi of 0.333?
P and Q.
P and Q. Okay. Then when I take phi of 1.333, what are the areas that I end up adding?
PQR.
PQR plus P plus Q plus R. Now remember that all of this is equal to what? All of this, the sum of all the areas is equal to 1. So when I subtract 1, what do I end up subtracting?
Sir, all of it?
All of them. P plus Q plus R plus P. Okay, now notice what happens. We have P plus Q plus P plus Q plus R minus P minus Q. This is not something that you have to do it all the time, but I'm doing this right now so that you understand the concept behind it. Okay, now notice what happens. P minus P gets eliminated, Q minus Q gets eliminated, P minus P once again gets eliminated, R minus R gets eliminated, and what are we left with? We're left with Q. Okay, so this is the reason behind why we do what we do. Okay, all right, this is not necessary. This working is not necessary. Okay, this working is not at all necessary. Okay, now, so what is phi of 0.333? I'm going to open up the answer, and I want you guys to read the table and tell me phi of 0.333. Okay, so the correct answer is 0.539. Okay, so the correct answer is 0.6304 is phi of 0.333. 0.9087 is phi of 1.333. Okay, and then when you subtract 1, in the end you end up getting 0.539 as the final answer. Okay, now any questions? If yes, feel free to ask. If not, let's do part B. Okay, now let's have a look at part B. Part B says the weights of bags of rice produced by binders are normally distributed with mean 2.55 and standard deviation sigma kg. Okay, so that means now we're talking about, let's call this y since we've already considered x. So y is normally distributed with mean 2.55. Okay, and standard deviation is and the variance is sigma squared. Okay. Now the question says, in a random sample of 5,000 of these bags, 134 weighed more than 2.6 kg. Okay. So that means in a random sample of 5,000 of these bags, 134 weighed more than 2.6 kg. So what is the probability of x being greater than 2.6? It's going to be 134 upon 5,000. Okay, I repeat, the probability of x being greater than 2.6 would be 134 upon 5,000. Why? Because 134 is the favorable, 5,000 is the total. Okay, so what's 134 over 5,000? First, let's work that out. 134 divided by 5,000, that's equal to 0.0268. So that means the probability of x being greater than 2.6 is equal to 0.0268. Now, first of all, before I solve this question further, tell me what's the difference that you see in this question and the questions that we've solved so far. We've solved, what, 2-3 questions now? But tell me what's the difference that you see.
So right now we're like doing reverse working.
Yes, right now we have the probability, okay, and we're not given the standard deviation. Now, the way that we got this probability was through z-score, okay, the way we got this probability was through z-score, okay. So, first thing we need to do is, this although is the probability of x is greater than 2.6, but this probability has come as a result of us reading the table of the, or reading the z value, which came from 2.6 being converted to the z value. Okay, this 0.0268 is the table value of z. And how did we get the table value of z? We got the value of z by converting this x value to z value. Okay, so z is equal to x minus mu. Let me write that again. Z is equals to x minus mu over sigma. So what's x? X is 2.6 minus sigma, which is given to us as 2.55, divided by sigma, which we don't know. Okay, so what do we get? We get, well, we can't simplify this any further. Okay, so we'll leave it here only. So this is what z is equal to. This is what z is equal to. Now the probability of z being greater than 2.6 minus 2.55 over sigma is equal to 0.0268. Okay, now the probability of z being greater than 2.6 minus 2.55 over sigma is equal to 0.0268. Okay, is everyone following so far? If yes, if you have any questions so far, feel free to ask.
Sir, could you please explain this again?
Okay, now normally what happens at this point is we're able to find out the z value. Okay, and we replace the z value with whatever it turns out to be. Correct? Just like how we did it in the previous part. We were able to find out the z value and we replaced the x value with the z value. Here we can't find out the z value. What do you think is the reason behind that? What do you think is the reason behind us not being able to find out the z value? Because we're not given the standard deviation. That's correct, because we don't have the standard deviation. So technically, this is what z is equal to, right? Technically, this is what z is equal to. 2.6 minus 2.55 over sigma. You can go ahead and simplify 2.6 minus 2.55. Yeah, of course, you can do that. You can write it as 0.05 over sigma. That's perfectly all right. Okay, in fact, let's do that. One less step of working to do now. Okay, now, the thing is, if let's say we had the value of z, okay, if let's say we had the value of z and we had to find out the probability of z being greater than a certain value, okay, how would we have done that? Here's how we would have done it. We would have done 1 minus phi of whatever value of z that we were able to find out. Basically 1 minus phi of 0.05 over sigma. Is that correct? And this would have been equal to 0.0268. This is what we would have done. 1 minus phi of the z value would have given us the probability, which is 0.0268, which is what we are already given in the question. So is this step clear? Why are we doing 1 minus? Because we have to find out the probability of greater than. Okay? Now, let's make, since the unknown is right here, let's make this the subject. Okay, and if I want to make this the subject, that means this will be 1 minus 0.0268, which is then equal to phi of 0.05 over sigma. Okay, So 1 minus 0.0268 is equal to 0.9732. 0.9732. And this is equal to phi of 0.05 over sigma. Now phi is like a function, okay? So if let's say you have sine x, which is equal to 0.5, what happens if you take sine across the equals to sign in order to find out the value of x? What happens? When you take sine across,
inverse.
we take inverse. That's correct, 9732. Now here, if I take phi across the equals to sign, that means now I'm looking for phi inverse of 0.9732. Okay, now what do you think we mean by phi inverse? What do you think we mean by phi inverse? What are we going to do now, considering that it's phi inverse? Think about it.
So like we look at the values on the table and then
That is
backtrack it.
correct. Now we're going to read the table backwards. Now we're given the probability and we need to find out what is the corresponding z value. Okay. Earlier we were given the value of z for which we were finding out the value of p. Now we're given the value of p, p is for probability, or we're given the phi value, and now we need to find out what is it the phi value of. Okay. So that means we're going to do something we haven't done so far, which is reverse reading the table. Okay, now reverse reading the table is just as easy, or you can say as difficult as reading it normally. Okay, so keep the value in mind. I would suggest you write it down somewhere so you don't forget. 9732. Okay, now we're going to see in these values, correct to 1 or 2 decimal places, the closest that we can get to 9732. So one thing that I would suggest is always try and see these values first. Okay, these are some standard values. Okay, if you can find the answer here, that's great. If you can't, then you'll have to read it normally. Okay, so these are some standard values. So p is 0.9732. No, we don't have, we have 0.975, we have 0.99, but we don't have 0.9732. Okay, so this table is not going to help. Okay, so 0.9732, let's see what's the closest we can get. 0.9732, so this is 0.96, this is 0.97. Okay, now we're lucky. You know why we're lucky? Because we found exactly 0.9732. What if, let's say, we had found 0.9730? Okay, let's say, hypothetically speaking, this is not 0.9732, let's say this is 0.9730. Okay, and what is the corresponding z value? The corresponding z value is 1.93. Now we don't want 0.9730, we want 0.9732. Okay, and the value right after 0.9730 is 0.9738. Okay, which means this is not the value that we want. So what if this was 0.9730? What do you think we would have done? 1.933. Okay, let's see. Then we would have come to this column. We would have seen that what should be the third decimal, so that in the end we have to add 2. Why? Because we have found 0.9730. We want 0.9732. That means in the end we got to add 2. So where do I find the 2 over here? The 2 that I find is basically the corresponding value of 3 or even the corresponding value of 4. So it could have been 3, it could have been 4. Either way we would have been right. Okay? But here, like I said, we've been lucky because we found exactly 0.9732. And what is 0.9732 the corresponding value of? It is the corresponding value of 1.93. Okay? So now we go back. We found out phi inverse of 0.9732, 0.05 over sigma. Okay, I forgot what it was. It's 1.93. Okay, now let's find out sigma. 0.05 divided by 1.93. We have sigma is equal to, remember, 3 significant figures. Okay, 0.0259, and that is the correct answer. If that was the case, we could have used any of the 2 values. Yeah, we could have used any of the 2 values. In which case we will have like a... And normally when we give our answer correct to 3 significant figures, which we have to, we will get away with it, irrespective of the number, or irrespective of the value that we use. Okay, because correct to 3 significant figures, the values with both the answers would have been the same. Okay? Yeah. So just a minute, let me just quickly summarize what I've done. So basically, let me connect it with the first part. In the first part, we were given the value of x, which we then had to convert to the z value, or we had to find out z-score of both the values, and then we had to use the table to find the probability. Okay, that's part A in a nutshell. To cut the story short, for part B, we are given the probability, okay, we're given the mean, but we're not given the standard deviation. Okay, so if you're given, and you're given the value of x also, so the way to convert the value of x is to use this formula, but the problem is that we can't find out the exact value of z because we don't have the standard deviation, but we've been compensated. How? By giving the probability. So this is what we would have done here. Ideally, here we would have had a value of z if we were known the value of sigma, but since we don't, that's fine, nothing to worry about. We take, since it's greater than, that means the way to find out the probability of z being greater than 0.05 over sigma would have been 1 minus phi of 0.05 over sigma, which we know is equal to 0.0268. Now, since we have to find out sigma, we make sigma the subject. That means we bring 0.0268 across the equals to sign, and we take this across. Now we know that phi of a certain value is equal to 0.9732. That means we know the probability. We don't know what it's the probability of, or what is the z-score of which the probability is 0.9732. So now 0.9732 is what we're going to read from the table, but we're going to read it backwards. Why? Because when we take phi inverse, this is what we get. So phi inverse of 0.9732 turns out to be 1.93, and now there you go, you cross multiply, you find out the value of sigma. Yeah, go ahead, what's your question? And anybody else has any other question, please feel free to ask.
Like, could you explain it once more, but like do it the other way if we were not given the probability?
Oh, sorry, I don't know where that came from. If you were not given the probability.
So like if you were given the probability, like it would be much easier to compare those both of them.
But here we are given the probability. What's your question? दोबारा से बताओ.
Like, sir, I just want you to explain it like the way it was done first part. Like, explain it if you were not given the probability and we were calculating the probability.
Oh, okay. देखो, if you were not given the probability, that means we would have been given the standard deviation as well. Okay, so we would have first found the z value, and we would have been able to find the z value. Okay, the z value would not have been in terms of sigma or in terms of mu. We would have been able to find the z value. And then, since it's greater than, so first we see what the standard rule is, the standard rule to find probability. So because it's greater than, what we'll do is we'll do 1 minus phi of that z value. Okay, or 1 minus the probability of that z-score. Okay, which would have given us the probability of greater than. But here we're given the probability. So we use that probability in the same equation, and we make phi of 0.05 over sigma the subject, and then when we take phi across the equals to sign, that's like taking phi inverse, which means now we have to read the table backwards. And now that we're reading the table backwards, we will see the probability values and see what value of p corresponds to this, or what value of z corresponds to this probability. Okay, so once we have that, we replace it with this, and then we cross multiply and we find out sigma. That's what we've done.
Okay, sir.
Okay, so just a mental note that if you have phi inverse, that means you're reading the table backwards. Okay, I'll write it down over here. Phi inverse means you now have to read the table backwards. Okay. All right. Now I'll give you guys some questions to solve. I'll start with some easier questions. Okay. And so here's how this works. The probability that x is less than minus 2.4. That means whatever the phi value is, you don't have to subtract it from 1. Unless, of course, it's negative, then you have to subtract it from 1 for a different reason. Okay. So the first thing you do is you convert the z value. You convert this to z value, which means minus 2.4 minus 1.5 over sigma, which is 3.2. So z is equals to, let's see what we get. minus 2.4 minus 1.5 divided by 3.2. So z becomes minus 1.219. Okay, minus 1.219. This you can only take, this you have to take correct to 3 decimal places because you can read the table to 3 decimal places. Okay, so finding the probability of x being less than minus 2.4 basically means finding out the probability of z being less than minus 1.219, and finding out the probability of z being less than minus 1.219 basically means finding out phi of minus 1.219, and finding out phi of minus 1.219 basically means what? Means doing 1 minus phi of 1.219, since we know that the table doesn't have any negative values, so that's why we do 1 minus. Okay, now what's phi of 1.219? Anyone who's figured it out? Phi of 1.219? Okay, so 1.2, let's clear the table. 1.2 means here, 1.21 means 0.8869. So 0.8869, and since it's 1.219, so we carry on in the same row, and 9 means in the end we add 17. Okay, so use a calculator for this. 0.8869 plus 0.0017. So we're looking at 0.886. All right, so we're looking at 0.886. So 1 minus 0.886 gives us what? Gives us, let's see, 0.1114. 0.1114 is the correct answer. Okay, but fairly easy question. Still a lot can go wrong, especially when it comes to reading the table. Okay, now solve this. And the mean is 1.04, in case you can't read it clearly. Mean is 1.04. This is very similar to the question that we just solved, the first past paper question, the second part of the first past paper question. Yeah, it's 0.0334 only. Okay, I'll solve it. So here it is. We are given the probability of x being greater than 1.1. The probability that x is greater than 1.10 is 72 over 2000. Okay, why is that? That's because the question says in a random sample of 2000 bags, 72 weighed more than 1.1 kg. So the probability of x being greater than 1.10 is so and so. Acha, x, what's x? X is a variable which is normally distributed with mean 1.04 and standard deviation sigma, which means variance is sigma squared. Okay, so first of all, let's find out 72 divided by 2000. That's going to be 0.036. 0.036. So this is what? This is the p value. What is this? This is the p value. Okay, now here's how we do this. If we find out the z value, the way to find out the z value would be 1.10 minus 1.04 over sigma. Okay, so the z value now becomes 1.1 minus 1.04, which is 0.06, 0.06 over sigma. That means the probability of z being greater than 0.06 over sigma is equal to 0.036. Okay, the more layers you add to your working, the better it is. Even though it's a 4-mark question, but just add as many layers as possible. Okay, now the way to find out the probability of z being greater than 0.06 over sigma would be to do 1 minus phi of 0.06 over sigma, which is then, as we can see, is equal to 0.036. Okay, so far so good, I hope. Then when you take it across, the equals to sign, when you take this across the equals to sign and this across the equals to sign, here's what happens. 1 minus 0.036, so we're looking at 0.964, which is equal to phi of 0.06 over sigma is equal to 0.964. Okay, now 0.06 over sigma is now equal to phi of 0.964. Once again, we go back to the table. Now this means we have to read the table backwards. So let's see if we can find the probability over here. Nope, not lucky enough. And what is the probability? It's 0.964. Okay, so I'm just going to write it down somewhere so I don't forget. 0.964. So 0.964. We see 0.9641. There's no point in looking at values on the right side of it because they'll be greater. So we're looking for 0.9640. Okay, might as well add 0 so we don't get confused. So this is the value that we find. We find 0.9633. Now what should we add so that we get 0.9640? What should we add? What should be the last digit? What should be added in the last digit? 7. Okay, where do we find 7? We find 7 here. That means 1.799. No, wait a minute, that's 17. 1.798. Yeah, 1.798. Okay, which is why it's important that you whatever working that you have to do on the z table, use a pencil. Okay, you don't want to end up getting confused from an older value. Okay, so this is 0.9633. We want another 7 in the last digit so that it can become 0.964. So how do we make this 0.964? 1.798. So now we know that the phi inverse of 0.964 is basically 1.798. 1.798. Okay, so let's find out sigma. 0.06 divided by 1.798. That gives us 0.03337, which then becomes 0.0334. Yeah. So sigma is equals to 0.0334. Okay, so correct to 3 significant figures, your answer should be exactly what it says in the marking scheme. Alright, now are you guys getting the hang of it? Okay, especially the ones who are doing it for the first time. Those who have done it before, I'm not too worried about you. But those of you who are doing it for the first time, I hope you're now getting the hang of it. Achha, now since these questions are lengthy, I don't want to rush and start the next concept immediately. What I would like to do is, I would like to give you guys some more questions to solve instead. I know, too many rules to remember. But देखो वही बात है उबैदुल्ला. I agree you have too many rules to remember, but you can always figure out, or you can always work it out there and then by just going the extra mile. By going the extra mile, you can figure it out. Okay, you're talking about these rules, right? Where you have to subtract, where you have to add, subtract, all of that. Okay, dekho, let me tell you something. If you can just remember 2 rules, with the help of that, you can remember all the other rules. Okay, what are the 2 rules? Rule number 1 is that if you have to find if you have to find out the probability of z being greater than, you do 1 minus phi of a. Okay, if you want to find out the probability of z being greater than a, you do 1 minus phi of a. That's rule number 1. Secondly, if you can remember this, that in order to find out phi of minus a, whether it's for greater than or whether it's for lesser than, in order to find out phi of minus a, you do 1 minus phi of a. Okay, if you can remember these 2 rules, okay, one for greater than and one how to find out phi of a negative value, all the other rules will fall into place. Why? So here it's greater than. Greater than means you'll do 1 minus phi of whatever it is that it's greater than. Okay, that's rule number 1, the first rule that you have to remember. The second rule, that if it's minus, well, what do you do in that case? You do 1 minus phi of a. So minus minus cancels, and this is what you have to remember. This is what you end up with. Here, no rule to remember, phi of b minus phi of a. Here, once again, just one rule that we're going to use. We'll do phi of b minus phi of a, same as what we did earlier. Now, how do we fix phi of minus a? For this, we use the rule that if it's phi of a negative value, we do 1 minus phi of the positive value. We use that rule, we automatically find out what we have to do. Here also, we're using the same rule. Phi of minus b can't be worked out, so we do 1 minus phi of b. Phi of minus a can't be worked out, so we do 1 minus phi, we do 1 minus phi of a. And then we simplify, we know exactly what we have to do. Okay, so just 2 rules, if you can remember, you can figure out all the other rules. Alright, I hope that helps. Okay, now You're welcome. Solve this question. Okay, so the correct value of t is 9.22. Value of t is 9.22. Okay, now I'll solve. I want you guys to pay attention. Here's how this works. On 75% of the days, PR takes longer than t minutes. So that means the probability that x is greater than t is 75%. And 75% means what? 75% means 0.75. Okay. So the probability of x being greater than t is equal to 0.75. Okay. Now, because we're talking about greater than, that means we'll have to do, first let's find out the z value. Okay, so the way to find out the z value would be t minus, what's the mean? The mean is 10.1 divided by the standard deviation, which is 1.3. So that means the probability of t minus z being greater than, the probability of z being greater than t minus 10.1 over 1.3 is 0.75. Now, how would we find out the probability of greater than? Here's how we'll do it. We'll do 1 minus phi of t minus 10.1 over 1.3, which is equal to 0.75. Okay, now this is an interesting case. Okay, this is an interesting case, which is also a possibility that we might have to deal with. Okay, and sadly, that means there's another rule that you guys have to remember. Okay, but not a complicated rule, not at all a complicated rule. Okay, so when you do 1 minus 0.75, which is equal to phi of t minus 10.1 over 1.3, this means that you're left with phi of t minus 10.1 over 1.3, which is equal to 0.25, which means we now have to find out phi inverse of 0.25. Okay, which means we now have to find out phi inverse of 0.25. Okay, now tell me, what's the problem over here? What is the problem over here? Anyone who can highlight what the problem here is? We have to find out phi inverse. So I'll take you to the table and now you can tell me what the problem is. It's a small value. Okay, no value of p is less than 0.5. What do we do now? Okay, for this, since we're doing it for the first time, it's okay if you're not aware. I'll tell you what we do. Okay, so here's what we do. I'll write down a note, okay, and then you guys can follow that rule. So the note is as follows. The note: if the value of p is less than 0.5, okay, if the value of p is less than 0.5, here's what we do. Simply subtract p from 1 and multiply the other side by minus 1. Okay, simply subtract p from 1 and multiply the other side by minus 1. Okay, that means I cannot take phi inverse of 0.25. Okay, not a problem. Here's what I'll do. I will instead take phi inverse of 1 minus 0.25. Okay, and consequently I will multiply the other side by minus. Okay, consequently I'll multiply the other side by minus. Okay, so what is phi inverse of 0.25? Phi inverse of 0.25 means phi inverse of 0.75. Now here we are at an advantage. Okay, we have a small advantage over here because we know the corresponding z value of 0.75. The corresponding z value of 0.75 is 0.674. So that means phi inverse of 0.75 is 0.674. Okay, 0.674, which is equal to minus t plus 10.1 over 1.3. Okay, so cross multiply 0.674 into 1.3 minus 10.1, and then don't forget to cancel out the minus sign. So t is equals to 9.22 seconds. Seconds hai, minutes hai, khair, that's irrelevant. It's minutes, yeah. So 9.22 is the answer. Okay, so another concept learned, which is that if the p-value is less than 0.5, nothing to worry about. We subtract it from 1 and we do 1 minus the answer.
So 59.
57 is the correct answer. And the probability that you would get, which will give you 59, is 0.644. Okay, now I'll solve this question. We probably made a calculation error, but again, an error is still an error, so just try and avoid making those errors. So first of all, here's what we're doing. We need to find out the probability. Before we can find out the number of days, we need to find out the probability that she takes less than 11.3 and greater than 8.9. Okay, this is what we have to find out. So first we need to find out their z values. Okay, so the z value of 11.3 we already have. The z value of 11.3 turned out to be, what was it? Okay, let's just quickly find it out. So 11.3 minus 10.1 divided by 1.3, it was 0.923. Let's say, yeah. And what about the z value of 8.9? Z value of 8.9, let's work that out also. 0.8.9 minus 10.1 divided by, surprisingly this is minus 0.923. Okay, minus 0.923. That means we don't have to find out the z values of two different values. Okay, so how we'll work this out? We'll work this out by taking phi of 0.923. From this we will subtract phi of minus 0.923. Okay, the standard rule that we follow. Now in order to find out phi of minus 0.923, we'll do 1 minus phi of positive 0.923. Okay, 0.923. And the good thing is we've already worked out phi of 0.923. Correct? So this becomes 2 phi of 0.923 plus phi of, there's a bracket over here just so you know, plus phi of 0.923 minus 1. Okay? Sorry, 2 phi to ho gaya na already. Okay. Minus 1. Alright, so phi of 0.923 is 0.822. Okay? And then don't forget to multiply it by 2 and minus 1. So 0.822 times 2 minus 1. So in the end, the probability that we're looking at is 0.644. Okay, this is the probability for 1 day. Okay, what about 90 days? For 90 days, we'll multiply this by 90. So here's what we get. Into 90, we get 57.96. So 57.96 days doesn't make sense. Since we're talking about number of days, it's either going to be 57 or 58. So even though it's very close to 58, but it's still not 58 days. Okay, so the final answer would be 57 days. So don't just brainlessly round off. Make sure that you see the context of the question as well and what value it is that you're rounding off. So rounding off the number of days, rounding it up doesn't make sense because the 58th day is not completed. So it's going to be 57 days only. Okay. So why did you multiply by 90? Read the question. It says, on how many days in a period of 90 days would you expect? Okay, for 90 days. The probability that we find out is for 1 day, on a randomly chosen day, That's what the question says. But for 90 days, you would then multiply it by 90.
Sir, how was your z value coming 0.822? Can you show that?
Yeah, sure. It's 0.923. 0.923. Okay, 0.923. So here's 0.9, here's 0.92, and then here's 0.923.
Okay, sir.
Okay, so 8, 2, 2, yeah, 8220 basically. 8 to 20, yeah. Okay, so we'll keep it till here only. I'll give you guys homework and I might keep an extra class tomorrow, okay, because we didn't, although normal distribution is lengthy, so it was what we did today was important practice. We didn't do it for any other topic like we did today. So I might keep a class tomorrow to cover the remaining concepts of normal distribution. Not the remaining concepts, but like to solve the remaining variations that we come across in normal distribution. Okay, and the questions that you guys have shared, we will keep a class for that. I'll either explain it on the group or we'll keep a class for that as well. Okay, yeah, tomorrow will be a P1 class. I'll let you guys know in the group when it